So here's a second example doing a similar thing. The only thing that we have to be careful with in this example is when we think about all the stuff that's affecting your x, everything that's horizontal. We've got a horizontal reflection and a horizontal translation in this example, but it hasn't been factored out. So we have to take one extra step where we factor out that negative. That would make this x minus 2 up in the brackets. They already told us what our parent graph is, y equals 2 to the x. So I do find it helpful, especially with exponential ones, that I take out a different color pen and I just put a box around the 2 and the x to remind myself that's part of my parent graph. So I don't have to worry about that in my transformations. Because sometimes when you're working left to right, you just see the next number and you do something with it, just because you're in a mode of working from left to right. So hopefully that can help you realize, okay, that 2 and the x, that's part of my parent graph, and I don't need to use that in my transformations. So how do we go about graphing this? Well, we would start with our parent graph, draw a quick sketch of it off to the side. Two to the x has 0, 1, and 1, 2, and of course an asymptote at y equals 0. And we use that to figure out the points on our new graph. So what's going to happen to 0, 1, 1, 2, and our asymptote y equals 0? From left to right, first of all, we'd run into horizontal stretches, compressions, reflections. First number we hit is the 3. That's going to multiply our y by 3. And then we hit a negative, which is a negative 1. That's going to multiply our x values by negative 1. So instead of 0, 1, we have 0, 3. Instead of 1, 2, we have negative 1, 6. Then moving from left to right, the next number we hit is a minus 2. That means that we are going to go right 2, and we don't move up or down because there's no number at the end. So moving 2 to the right, we'll take this point to 2, 3, and this point to 1, 6. Doing the asymptote at the end. Again, the only thing that's going to change your y equals 0 asymptote is whether your graph gets moved up or down. Multiplying won't affect it. Moving it left and right won't affect an asymptote that's horizontal. And so this one doesn't move up or down, so we still have an asymptote at y equals 0. Putting that all together, start by graphing your asymptote, y equals 0. Plot your points. So we've got 1, 6 and 2, 3. Because of those points, you'll know the shape of your graph looks like this. Now that we have our graph, we can answer some of the characteristics. Is this new one increasing or decreasing? It's decreasing. The intercepts. Well, the intercepts don't show up on my graph. I know that there's no x-intercept because I have an asymptote at y equals 0. But I didn't label my y-intercept. Question is, what is this point right up here when x is 0? Well, how do we find a y-intercept? Plug in 0 for x. If I plug in 0 for x here, can you see that you're going to get 2 to the power 2, which is 4, times 3. You'd get the point 0, 12. So we can add that in, that our y-intercept is 12, and that there are no x-intercepts. Our asymptote is at y equals 0. The domain of any exponential function is always everything. And our range will be y is bigger than 0. So I'd like you to take some time right now to try number 10.